Hello and welcome to Thursday's edition of Cracking the Cryptic, and a huge thank you from me if you are watching this video on Thursday rather than watching the Masters Golf from Augusta, which is what I shall be watching later on. No, I am most grateful, and I'm going to try and do my best to entertain you, if that's possible, for the next however long by trying to solve a puzzle called 3 is a Crowd by none other than Dying Flutchman. And I haven't done a Dying Flutchman puzzle for yonks. And Dying Flutchman is a brilliant constructor. And I think has been on hiatus. I certainly am unaware of any new Dying Flutchman puzzles in the last year, I want to say, maybe even longer. But the testers have had a look at this and they say it is really, really clever. And you can see that there are sort of circled cage totals, and the idea is that I was going to say 3 cells along the line, but 3 consecutive digits along the line, or numbers along the line, have to sum to a multiple of 3. So if you look at that cell, but then there's this circle in between, so that cell, and the number in between have to sum to a multiple of 3, and then the circle plus those 2 cells would have to sum to a multiple of 3 as well. So every sort of 3 consecutive thingies along a line, thingies is the technical term, have to sum to a multiple of 3. That is all there is to the puzzle. I will do the rules formally and properly in a moment or two's time. I have no idea of the difficulty of this. I'm going to guess at average difficulty, but that could be a woeful. I doubt it's an overestimate. Dying Flutchman's puzzles from memory are not necessary. They're not normally easy, so it could be harder. But I'm going to guess average. Anyway, we'll have a look at this in a moment or two. Huge thank you, not just for watching this video, but also to those of you who joined us last night when we streamed for the first time in ages. We attempted this game, Monument Valley, and what a beautiful game this is. If you've not tried it, I really think everybody would enjoy it. It's not monstrously difficult, but it does have difficult moments, and it is, if you like the art of Escher, and who doesn't, it'll leave your jaw on the floor. It's really good. Now there is a sequel, Monument Valley 2, and I'm going to try and persuade Mark that we should do another stream where we try and tackle that one in due course. So look out for an announcement about that in the coming days. What else can I tell you about? Over on Patreon, our competition for the month of April is running, themed on April Fools. So all of these puzzles involves a tricky April Fool's theme, and we had 303 solvers of all the puzzles as of yesterday. Let's reload. 348. Fabulous work from all those of you who've managed to do it. Look, 1,333 have attempted the second puzzle. That is superb. I think part of this is because everybody is very interested in trying to win Emily Williams' rather wonderful cushion cover. Handmade, this is. Sudoku themed. And if you want to be in with a chance of winning it, then do get your entries to us. As I say, it's over on Patreon. Do join us there, and you'll find an awful lot of puzzling fun. And I have one birthday to do today, which is for Lorenza. Lorenza down there in Italy. Lorenza, you've turned 33 today. I gather the channel has proved something of a boon in terms of your Sudokuing life. I'm delighted to hear that. I'm delighted to hear you're having chocolate cake today. I hope it is incredibly heavily iced. And that's all the news. That's all the news. Let's have a look at 3 is a Crowd by Dying Flutchman, and I will read you the rules of this puzzle properly. We have got normal Sudoku rules apply. So we have to put the digits 1 to 9 once each in every row, every column, and every 3x3 box. Digits in cages sum to the indicated value. Some of the values have been replaced by question marks. So those 3 sum to 12. Those 3 sum to 17. But these 3 we don't know. It depends what the question mark is. White dots contain consecutive digits, so okay, so we've got sort of a symmetrical disposition of white dots. So if this digit was a 2, this could be 1 or 3 to be consecutive with 2. That's how white dots work. Now, along purple lines, any consecutive group of 3 values, digits or cage totals must sum to a multiple of 3. So I think this is what I explained earlier. So that's quite straightforward. Those digits, those 3 digits, they don't involve any nefarious activities. So those sum to a multiple of 3. But this one, and the circle must also sum to a multiple of 3. So it's a really unusual rule. We've seen entropic lines and modular lines before, but I've never seen this sort of rule involve cage totals. It's an innovation from Dying Flutchman. Do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. Okay, I think I can see some low-hanging fruit. An 8 cage in 3 cells must contain a 1. So there must be a 1 in both of these 8 cages, and that means the 1 in row 3 must be in one of those 3 cells, because it obviously can't be there and it can't be there. A 5 cage is either 1, 4, whoopsie, it's either 1, 4 or 2, 3. A 15 cage is either 6, 9 or 7, 8. Now 17 cages are a little bit less amenable to logic than the 8 cages were, in the sense that I don't think there is a digit that has to be in a 3-cell 17 cage. It could have a 1 in it, it could have a 9 in it. So we're probably going to have to use the funny old rule soon. Which of these lines is the most likely to be the obvious place to start? Or maybe I have to do some thinking first. Let's ignore the circle thing for a minute, because the circle thing's just going to confuse me. Those 3 digits, they are 3 consecutive cells along this sort of trapezium. Now, they sum to a multiple of 3. So, okay, no, I have to be a bit more careful than I was about to be. I was about to say that each of those digits has to have a different remainder when divided by 3, but that's not true. That, in fact, is very not true. They could... Right. Okay, so I actually think there are a lot of ways that these 3 digits could be comprised, and the way I'm thinking about this, just to share this, whatever value this thought has, I will explain it. I am thinking that each Sudoku number has a particular remainder when divided by 3. So if we think about the number 1, that has the remainder 1 when you divide it by 3. 3 goes into 1 0 times with a remainder of 1. 2 has a remainder of 2. 3 has a remainder of 0. So we can sort of, in our mentally, map the Sudoku digits into a set of digits 1, 4 and 7, all of which have a remainder of 1. 2, 5 and 8, all of which have a remainder of 2, and 3, 6 and 9, which all have a perfect. They all divide exactly by 3. So what you could have here, imagine if these digits were 3, 6 and 9. That would be perfect, wouldn't it? Then those 3 digits would definitely be divisible by 3, because each individually is divisible by 3. But you could also have, imagine these were 1, 4 and 7. Each of those individually has a remainder of 1 when divided by 3. So collectively they have a remainder of 3 when divided by 3, but a remainder of 3 is the same as being exactly divisible by 3. Now they could also be 2, 5 and 8, because each of those has a remainder of 2 when divided by 3. So 3 lots of remainder 2 is remainder 6. Divide the remainder 6 by 3 and it goes perfectly again. Or, and I think this might be the final or, you could have one of each. Because if you had a remainder 1 digit like a 4 and then a remainder 2 digit like an 8, then those 2 digits together have a remainder 3, which means that you add them together, you're going to get a number that's divisible by 3. And then you could have the 3rd digit being from the 3, 6, 9 set. So if we do something like, let's see, 4, 8, 6, we don't even have to add them up. We know that must be divisible by 3 because that's in the remainder 1 set, that's in the remainder 2 set, and that's in the remainder 0 set. So there are lots of ways. So either, well, okay, all right. But this is connected, isn't it? So those 3, whatever they are. No, this is a trapezium. Okay, this goes round in a circle. Let me show you what I mean. Whatever this is, it has a remainder when divided by 3. Now, these 2 cells, let's just group those together collectively. Because this is a sort of loop, I know that green plus double orange is equal to a number divided by 3. Exactly divisible by 3, but I also know that double orange plus this digit has the same property. So the remainder when this digit is divided by 3 must be the same as green. So those are both green. And now, if these are the same, then, okay, now look at that set of digits only. These are have the same remainder. Well, imagine this was a remainder 1. If this is a remainder 1, this is remainder 1, this would also be a remainder 1 digit. If these are remainder 2, this would also be a remainder 2 digit. And if this was a remainder 3, this would also be a remainder 3 digit. So that is also green. And now the line must be entirely green, because then we can look at that set. And obviously that must be 3 of the same in order to be perfectly divisible. So I don't know what the nature of green is. We've discovered green, my lord. That's Blackadder, isn't it? But we do know. Well, okay, no, I do know something. I really do know something. Green is not from the 3, 6, 9 set. Because if it was, these 2 digits would be selected from 3, 6 and 9. Let's pick the lowest, 3 and 6. They already add up to 9. But that cage adds up to 8. That's impossible. So green, can it actually be... Oh no, it could be 2, 5, 8. It could be 2, 5, 8. If that was 2, 5 and this was a 1, it could be. Okay, so green is either a 2, 5 pair with a 1 here, or a 1, 4 pair, because it couldn't involve a 7, it would break again. 1, 4, and this would be a 3. Oh, bother. Okay. I don't think this is right. Well, okay, here's another thought then. These 3, there are 2 versions of 8 cage in Sudoku. 134, 125. These can't be the same version. Because imagine they were both 125 cages. Then these 4 digits in row 1 would all be selected from just 3 different numbers. So that's obviously impossible. So the nature of this cage is different from the nature of this cage. Oh, bobbins, I don't know what to do with that. I'm going to move on to this one because I can see something fairly straightforward about this one. 3 digits along a line add up to a number divisible by 3. So this digit, and this digit collectively are divisible by 3. But if we look at that, the corpus of those two, we know adding this digit to the blue digits results in a number divisible by 3. And we know that adding the circle to the two blue digits creates a number that's divisible by 3. So we know... Well, what do we know as a result of that? Hang on. Do we know anything as a result of that or not? I want to say... yes, okay, so the... Because... this digit... Hang on. I think I'm going mad now. This is not a good thing to happen in a puzzle, by the way. Don't go mad. Hang on, if those 3 are divisible by 3, which they are... yeah, okay, so this question mark... I don't know. I see. I don't know what it is. I was going to say it's got to be 3, 6, or 9. That's not true at all. Because, of course, it is the cage total. So it could be 20... no, it couldn't be 27, but it could be 21. It could be 21, couldn't it? But okay, but this digit is divisible by 3. And we know that because we know that the cage is divisible by 3, because these 3 digits are divisible by 3, so that total is divisible by 3, and this total shares its modularity with this digit. So that is, oh, it's not a 3, that's a 6 or a 9. But this is really annoying. Because that means I don't know the nature of blue. I don't quite know the nature of green, but I really don't know the nature of blue. Because blue could be... imagine both of those were divisible by 3 digits, like this one. Then the cage would obviously add up to a multiple of 3, which is fine. But if these were different modularity and neither of them was 3, so say this was 4 and this was 8, then again it would work. So I don't know what that is, I don't think. I think these are either the same as this, or they're both different from this and from each other. Wow, okay. Sorry, that's not clever, is it? Right, okay, but alright, having learnt from this one, I'm going to use this one. Because those 3 digits are clearly divisible by 3, because they are consecutive along the line, which means that the total for this cage is divisible by 3, which is that circle there. So if we count 3 units along the line, circle 1, 2, that digit there is also a 3, 6, 9 digit, therefore, because it must be divisible by 3. So it's from the same set as this one. Now, right, this is better. Right, this is better. I'm actually going to award this a colour now. What colour should we have for 3, 6, 9? I don't want to use green. I'll use red or yellow, do you think? Yellow, maybe. That would be a nice thing to do. So that one's yellow. But what I was going to say is let's think about how this cage is constituted. Because obviously for that cage to be divisible by 3, both of these digits could be yellow. Except they can't now, can they, by Sudoku? Because this is yellow, you can't make both of those yellow as well. There'd be 4 yellows in column 4, and there's only 3 such numbers with a 0 remainder, 3, 6 and 9. So these have to be one of each of the other types. So one of these is from the 147 set, and one is from the 258 set. So let's make those colours and see if we can. I'd love to know if this was. Oh, hang on. Well, we know green. Oh no, one of these is green then. Oh, hang on. I'm already messing up my colourage. Yeah, one of these has to be green, because we know green is not the 369 set, don't we? So my colours are going to be yellow, orange and green now. Oh no, I quite want to use blue today. Yeah, I'll do that. That's lovely. Right. Okay, so this one has to repeat there along the line. And this one... Oh, I see, this is really... This is awkward now. Okay, I'm going to change this to being green or blue. And I'm going to actually allocate these two. I'll make that green and that blue. And the reason I want to do that is I can count 3 cells along the line and then fill them in. So I know these two are the same modularity. I just don't know what that modularity is, apart from it's not 369. And that one is the opposite modularity. Now, if the 15 cage was 6/9, it would be double yellow. Which one should we do next, do you think? Should we work top down or bottom up? Or I'm not sure. I'm going to try this one now. You see, this one's more awkward. Immediately it's more awkward because those 3 digits are not consecutive along the line. It goes doop-de-doop-de-doop there. So I don't know whether this cage is divisible by 3. I know those two are the same. They have the same modularity. I'm just going to use just a random colour to record that. So, in order for this... Oh, hang on, this is confusing me. So that one is the same as this one. That one is the same as the question mark. So this one is the same as this one. But any number of these colours might be the same as the other colours. So I can't assume anything here. I don't think. Oh, those are the same on the white dots. That feels weird. How could that be? Oh, these are the same number. There we go. That's a tiny deduction. Those are the same. And the way I'm getting that is from the white dot sequence. Imagine this was a 1, and this is therefore a 2. This is either 1 or 3, isn't it? But we know it has the same modular property. So if it went 1, 2, 3, 1 and 3 are not in the same modular group. They have different remainders when divided by 3. So in order for these to have the same remainder, they have to be the same digit. Right. And that digit is massive. I don't know how massive it is, but it's not. This is beautiful. This is not. A is not 1, 2, 3, 4 or 5. And that's for a lovely reason. The reason is, remember what we said about the 8 cages a few minutes ago? We said they were different flavours. So one of them is 1, 3, 4, one of them is 1, 2, 5. In other words, between those 2 cages, the digits 1, 2, 3, 4 and 5 appear within these 2 cages that I've just highlighted within these cells. So how could this A digit be a 1 or a 2 or a 3 or a 4 or a 5? It couldn't be, because it would prevent that digit appearing in whichever cage has that digit in it. And we know that 1s, 2s, 3s, 4s and 5s do appear somewhere in those 6 cells. So A has got to be, not only are these 2 digits the same digit, They are big digits. So A is over here by Sudoku. Now, let me think about this. I know that the sort of indigo colour is the same colour as the sum of the box. So if that's a 1 remainder digit, those two right. Okay, orange is the new yellow. I think it's not the new black, it's the new yellow. Okay, now the way I'm seeing this, which I'm slightly worried is not correct, but it feels right. All I'm doing is thinking about the remainder of this number when divided by 3, and I don't know what that remainder is. But what I can see is, so let's do an example with a 2 remainder. So in fact, let's make this add up to, so we need a number like 20. If this added up to 20, it would have a 2 remainder when divided by 3, wouldn't it? Now, that would mean this digit has to have a 2 remainder when divided by 3 because it has the same modularity as the circle. So this would be, in that instance, a 2, 5 or 8. But in order for the preservation of the remainder to work, overall this cage has to sum to a number that has the 2 remainder, the number 20 we said. But this itself has a 2 remainder. So these two, which are the same modularity, have to sum to a number that is perfectly divisible by 3 in order to not change the overall modularity of the cage. Now, imagine these were both 1 remainders then. Well, that doesn't work. That leaves the overall total here as a 1, and a 2. That's remainder 1 once you cancel it down. It's not the same. The only way that these preserve modularity is if they're both from the 3, 6, 9 set, and that is why I think that these are both yellow. I don't know, weirdly. Oh, I do know. This digit. Right, this is complicated. Right, hang on, let's just put that one in, because this is a 6, 9 pair now in row 4. Oh, this is right. I can see what this is doing. This is doing lots of things. But this digit, it could have been yellow. Because if it's yellow, those 3 are summing up to a yellow modularity, and so would the circle be. But it couldn't be. Because if it was yellow, then these 2 digits plus this ought to have a 0 remainder. And that would make this yellow, which would make purple yellow, and give us 4 yellows in the column. So indigo is definitely not yellow. It is red or blue. Red or blue? Blue or green? It's blue or green. And then this one. So now we know this cage adds to a blue or green remainder, depending on what this is. But we know those 3 add up to a number divisible by 3. So this is the opposite modularity to this one. Oh no, I've got a horrible feeling. You see, the thing is, now I know this one's modularity is different from this one, and the same as this one. But I don't know how to relate it to what's gone on down here, and I don't know how to relate it to this. This was all the same modularity. Oh, bobbins, I don't know. That digit is 3, 6 or 9. Oh, I'm sorry. I don't know how to deal with that at all. I don't really know how to even... This digit is 5, 6, 7, 8. I mean, that's such a bad pencil mark, but I'm just noting that it's linking two digits that are the same. So it could be as low as 5 if these are both 6s. But it can't be... Oh, no, hang on. No, hang on. This can't be 6. Right. But because we've just proved that these two digits are from the green or the blue modularity, which is not the 369 modularity. So these squares are 7s and 8s. This is not 5 then. Because it's got to be consecutive. This is either double 7 or double 8. And whatever it is, it's not able to appear. Yeah, oh no, oh no. You know what? I'm going to have to do this again. I think I'm going to start again with my colouring, because I did it down here. Because what I've noticed, imagine this was double 8. That's going to prevent... These three are of one... We know this whole trapezium is one modulus, which means this is either 147 or 258. In fact, that digit is 7 or 8, I suppose, is one way to think about this. But clearly this digit is not the same as whatever we've got repeating in those cells. So whatever colour these two are is different from this. And different from this. Oh, I don't know how to do this. So this one is the opposite of this. This one is the opposite of this. But that one is the same as that. So I'm wondering whether I should have coloured down here. I don't know. I don't know. I think I'm going to just try and remember that for the time being and hope that something simpler is going to emerge. Right, but I did spot something else. When I made this one yellow, one possibility here was that this was 3 yellows, wasn't it? Well, it's not 3 yellows now. So these two are one of each, blue and green, in order that that overall sums to a multiple of 3. Now, what does that mean? You may well ask. I don't know. Okay, what about those two? Can we get those two? They add up to 9, which is right. This is one of each. Oh, this is horrific. We know, because these have to add up to 9, which has a 0 remainder when divided by 3, they must be one of each modularity that is not yellow, because they could have been both yellow, except we've had all 3 yellows in box 5. So these are one of each. I mean, this is really... The hardest thing with this puzzle is actually not doing the puzzle. It's working out how to colour it consistently. What's going on with this one? This one is... Well, that cell is not yellow. That is green or blue. And 3 along from it, that cell is therefore green or blue. And it's the same as this one. Now... What does that mean? This one, whatever that is the same as that one. I'm just going to make that orange for the moment. and that one is the same as the sum. But do we know the way to San Jose? That is the question. So, but hang on, hang on. I also know those three add up to a number that's divisible by 3. So if orange is yellow, if orange is yellow, then this is blue. It's the opposite of this in order that that string works. And then, and then that would be... Oh, hang on, I don't like that. That didn't seem to work in my mind when I did that. This could be quite important. Okay, let me think that through again. I think I better think it out again. We're reviewing the situation. Right, let me think about this again. So what I was thinking there, which I don't know if it's a good thought or not, is if this was yellow. Now, I know these three together have to be divisible by 3. So the only way that can be the case is, let's say this one was blue, this would have to be green for the remainders to work. But now, those three together would be one of each modularity, which means that the sum total here should be yellow. But it wouldn't be yellow because this would be the opposite of this. So these are not yellow. This is, see, I don't even know. It's blue or green now. Again, okay, it's got to be different. It's got to be different for the same reason. If this one was the same as this one, so let's say this is double blue for a moment, then in order for this 3-cell string to be divisible by 3, that would have to be blue again. It would have to go blue, blue, blue. But then that's implying, oh no, hang on. Ah, no, this would have worked, but it doesn't. Oh, okay, I'm lucky. I didn't spot something here, but I have spotted it now. Right, so the way that this would have had to work is this was blue. And now we could have, we now know. Oh, wait a sec. Wait a second. So how would that work now? So 3 blues here, which makes this a blue. I get 3 blues in a row, but that's blue. That doesn't work. Yeah, it doesn't work. It just doesn't work because the alternative would be that I go double green here. If these are the same, in which case to make those 3 divisible by 3, that has to be green. And now, but 3 counting 3 on from here makes this green, which means this is 3 greens, which makes it divisible by 3. But green is not divisible by 3, yet it shares modularity with the sum. So it really doesn't work for a few reasons. There would also be 4 greens in the row as well. So what we've now deduced is huge, because it means these are different. But therefore, in order for these three here to be divisible by 3, that has to be yellow. And that means, and that works then. Although my colouring is up the Swanee. These have the same modularity. And these have the same modularity. And you can see it's really nice because we know that yellow is the total in the question mark, and we will have one of each modularity, providing these are different. So I don't know how to do this. Maybe I do that or something. just to indicate their different modularity. I can do that. I can do the same thing there. I can do, how did this one work? Those were different modularity. But these are the same. So these are different modularity. Oh, lovely. Right. Look at row 6. In row 6, I've put one yellow so far. Now, even if this was yellow, that would imply there's a yellow in the 15. Now, once there's one yellow in the 15, there's two yellows in the 15, because 15 is itself divisible by 3. So, this has got to be 6, 9, and is double yellow. Now, see, this is going to get even more confusing now, because this one now is obviously red or green. I think it's this. Yeah, these are different. These are different. These two are different. So these two are different. Oh, where's 6 and 9 in row 5 by Sudoku? They're there. That's huge, because now that's got to be a 3. And all of this, oh right. Well, this is massive. Hang on, sorry, we could have just cracked this puzzle open, because now there can't be a yellow in there. So this is not 2, 3, this is 1, 4, the same modularity. Oh, bingo. Oh no. Okay, I'm going to have to recolor. I'm going to have to. I'm really sorry, but oh, I don't know how I'm going to go about this, but you can now see these are both from the 1, 4, 7 set. And one of these is from the 1, 4, 7 set. So, okay, I'm going to have a totally new colour scheme. I'm going to go orange for these. One of these is orange. I'm going to say this is black then, which means this is orange across the 12 cage. This one we know is opposite of that one, so that one is black. This is one of each, so one of these is orange, so that one is black. And that the black is 258. Let's not forget that. So that's 258, because orange is 147. This is 147. This is 258. This is useful. Yeah, I think this is useful. I'm not having it. And oh, is that really a 258 digit? Well, how did I get that? How did I get that I knew what that was? Oh, I'm sorry, I've gone mad, I think. 1, 2. It's got the same. I don't know. I don't know why that's got 258 in it. I wish I knew. Because if that... Yeah, if that's 258, that's 7. I definitely do. Maybe I just put that in because I had it highlighted over here or something. I don't know. I don't understand. I don't think I do know whether that's 2, 5 or 8 or not. But right. How do we do this next bit then? This is one of each. One of each. These are the same, different from this one. So these are one of each. There must be one yellow. I'm just looking at column 6. This can't be yellow. So there is a yellow down here, and then 3 cells on this sort of, this trapezium is going to have a yellow on it. So if that's yellow, 1, 2, those two would be yellow. But if that's yellow, that would be yellow. So there's a... Oh! Ah! Okay, I'm going to use that. I mean, this is a mad point. But if... What I've just said is one of these is yellow. And we know to preserve modularity along these lines, every 3 cells, especially as this has no cage totals involved, are going to be preserve that modularity. So one of these is definitely yellow. Now look at that square then. That can't be 6 or 9 because one of these is yellow. There's the 3, 6, 9 triple in column 7 or in those 4 cells. So that digit is 7 or 8 and is not the same as A. So it is the same as that cell. So we'll call that B. Whoa, no, B. These are the same digit. And they are different modularity to A. So okay, so we can draw that in, can't we? Because we might as well. I mean, it's crazy, but we might as well. These are all. Yeah, okay. I can do that red line as well. Sorry, and the reason I'm doing this is I'm trying to get a grip. So now, whatever the colour is of this, black or orange, I know they look blue and green, but whatever this is, there's 2 of them there and 1 of them there, so that they get finished for the row. So if this was 1, 4, 7, that would be a 3. If this was 2, 5, this would be a 1. That would be a 1. Oh, bobbins, I don't know. Okay. All right, let's go and have a look at another place. And that place is going to be... I don't know. 1. Where's 1 in column 7? It's down there. Can it go in the 17 cage? If it went in the 17 cage, it would need to be with 7 and 9. Which might be possible, actually. Okay, that's not how to do it then. So let me think about this. Yeah, obviously to create runs of 3 of the 3 digits adding to 0 mod 3, we could have had 3 the same here. But that's going to make all of this the same, and that's impossible. Because I know one of these is yellow, so the whole thing would then be yellow, and there'd be too many yellows in column 6 and column 7. So I think this line does, within every stretch of 3 along this trapezium, it has one of each of the colours. These squares, therefore, are blue and they're from the blue-green panoply. Because these can't be yellow, because I know there's 1 yellow in one of those and 1 yellow in one of those. So we can't have more yellows. We're going to end up we'd end up with too many yellows on the line. I mean, this is very it's really hard. It's making me feel a bit dense. What was the puzzle we did yesterday? It was something like, this puzzle will make you feel really clever. Well, this one makes me feel really dumb. Can I... Oh, I don't know. No, I was about to say, could I narrow down the 12 cage, but I can't. It could have 8 in it. Could have 7 in it. Oh. Oh, where are the yellows in column 3? That can't be a yellow by Sudoku. You can't put 2 yellows in consecutive places on a white dot because they won't. I mean, the nature of yellow is doesn't contain consecutive digits. So you can only have 1 yellow there, which means these 2 are definitely yellow. And A is not yellow, so A doesn't go into that position. So there is a yellow on this. There is a yellow on here. Yeah, that's possible, isn't it? I don't think we know which of these is yellow. We just know one of them is. So this one has got to be our old friends green and... Oh, well, all of these are green and blue. We just don't know how to allocate them between orange and black. Oh, dear. Wow. Wow. What a puzzle this is. What? What on earth am I meant to look at here? I want to say it's this, but I don't think... Oh, 17, I suppose. One of these is divisible by 3. Oh, okay. Maybe I can do maths. One of these digits exactly is a yellow digit. Exactly one of those. But 17 is a 2 remainder digit, isn't it? Go 15 would be a perfect, and then we've got a remainder of 2 to get to 17. So what does that mean? I don't know, actually. This is so annoying. That's so annoying. It means that there is a repeated modularity in here. No, that's true. Actually, that is true. Because there can't be one of each in there. If there was one of each, those 3 digits would divide by 3, and they don't. They add to 17. So it's either got 2 yellows in it, which would have to be a yellow here, and then a 258 digit to make the balance, which would make that digit a 147 digit, and that digit a 147 digit, which might work. Or you don't have repeated yellow, but you must have repeated another repeated digit instead that's not yellow, which would have to be a 147 digit, because 2 remainder 1 digits would give you a net remainder 2 digit, of which is the nature of 17. So if it was that situation, this would be 258. And that would be... Oh, see, this is just going around in a circle. Okay, that digit is not a 1. I think that's what I get at. That's a big deduction. Actually, if that is a big deduction, I'm actually going to just think that through. I'm not sure it's true. Well, am I? No, I do think it's true. I do genuinely think it's true. Right, what I'm using here is the fact that one of these 2, because of my red line, one of these is from the 147 set. This is from the 147 set. And I think I've just proved that down at the bottom of column 8, one of these is from the 147 set. Now I'm going to go through that again to prove it to myself, to reprove it to myself. So what I said was the 17 is not made up of 3 different modularities. I think that's true. Therefore, the 17 has a repeated modularity in it. which could be yellow if this is yellow. But then I've got 2 yellows in here, which makes the other digit here a 258, which means that those 3 have to contain a 147 somewhere, because we've got a yellow, a 258, but those 3 are divisible by 3. So this would be a 147 in that situation. So if this is double yellow, this is a 147. But if this isn't double yellow, the repeated digit in here is not from the 258 set, because 2 lots of 2 remainders gets you to a net 1 remainder. 17 is not a net 1 remainder number. So you have to have 2 147 digits in here, but given that there's a yellow digit here, the 147 would be there, and again create a net triple of 147s in this column. So in fact what I could do, I could draw that. I know these are not the same. But I also know there's a 147 here, 147 here, 147 here, so this can't be a 1. The 1 is here, and that gives me this as a 1. So this is a 4. Oh no, come on. So if this... Okay, the 4 can't go in this 8 cage, can it? Because we said that we've got 1s, 4s and 7s are all down there in column 8. So that can't be... There's no 4 in this 8 cage, so this is 1, 2, 5. And the 1 is not there. And 1, 2, 5... Well, 2 or 5 is my black digit, remember? Definitely. So this is an orange and a black. One of these digits is 2 or 5. One of them is 1, which is from this set. No, right, now I can colour the top row, I think. Because remember, we said that this here... Oh, well, actually, look, this is 1, 3, 4. We know that because it can't be 1, 2, 5. So this has to be 3. This has to be 1, 4. And we know that this whole line now, because it's all the same colour, is now orange. It's from the 147 set. So this is all orange. Oh, all orange. Which means that one is the same as that one. That's orange, which means that this is 7. This is 7. These are both 8. These 2 are therefore from the black set. This is not 8. And there's an 8 in one of those 2 squares. Let's get rid of the A now. I think we've used our A logic. 3 is a yellow digit. And we've had all our oranges in row 1, so that is not orange, so that's not 1, which means this is 1 and orange. This is lovely. We're actually getting somewhere. That's a 4 by dint of orange. 4 is in one of those squares. Oh, look, we've got 1, 4, 7 approximately and 2, 5, 8. So those are both yellow by dint of sort of colouring logic. So they're 3, 6, 9. I think this is quite difficult, this puzzle. It's made me feel very, very dense. 7 is in one of those. But do we now know what this colour is? We know it's different from those 3 add up to a number divisible by 3. So this is orange. That's going to be important, isn't it? Well, it's 1 or 7 then. That doesn't actually, we don't know. Okay, these are both 369s. Probably I can get rid of the green and the blue from those two, in the hope that we know that that's not green or blue. One of these is green, or one of these is black. One of these is actually 7, isn't it? Oh, that's big. Right. Because there's a 7 here, there's no 7 in my 17 cage anymore. So it's not 197, so there's no 1 in it. So this is a 1. 1 is orange. That doesn't do anything. Where should we look next? Can we do... I don't know. Oh dear, oh dear. 3 is in one of those cells by Sudoku. I really would like... yeah, I can. Where's 1 and 4 by Sudoku in box 4? They are there. So these are both orange. They're a 1-4 pair. So now... So 7 must be in one of those two cells of box 5, which means this is not a 7. I know. Oh, hang on. Look, I've got my red line dividing these, so I know one of these is orange. This one can't be orange. It sees all the orange digits. It sees 1, 4, and 7. So that must be 7. That must be orange. All of these 3 are now all obviously black. So these are 2, 5, 8. Oh, I'm starting to feel a little bit less dense now. Now, did we conclude that these two had to be different? I think, yes, that was the original. That was my original colouring. Look, I firmly planted these with greens and blues. So actually, this one is black now. And these two are both, you've guessed it, orange. Oh, look, I couldn't. Oh, no, I couldn't. I don't know. I was going to say that has to be a 1 or a 4, but because I don't know that one, I can't say that at all. Oh, bother, I don't know then. Well, we know that orange is 147. We know this one is 258. Now, we know that... No, I don't know which way this goes. That could be 3 and 4, couldn't it? Wow. Okay, I'm stuck again. Unsurprising, but I am stuck again. 7 is nearly in the 17 cage down there by Sudoku. That's not 3 by Sudoku. I've got to put 2 yellows into the top row. I've only just seen that. So I shall do that and hope. I've got all my yellows in column 1. All your yellows belong to us. So these, which can't be orange or yellow, have to both be, you've guessed it, black. That's black as well, actually. This is a 258 triple. The 8 of which apparently is in row 3. So this is only 2 or 5. So these digits down here are no yellows, 1 black and 2 orange. So if it's annoying because if the 2 orange go there, that would be yellow to make the modulo of this work, and that doesn't look impossible. But if these were one of each, which would be the other alternative, then we would be on a net, so this would be a 2 remainder. So this digit is either yellow or black. And I think both options are possible. Probably. Okay. So these squares are yellow and black. Gosh, I'm sorry if this is obvious to everybody. It's definitely not obvious to me. Wow. One of these is yellow. But the yellows are arranged in diagonals here, aren't they? I do know one of these is yellow, so this 17 has 6 or 9 in it, in these two cells, because it doesn't have 3 in it. Okay. I don't know, sorry. This is... Oh, why have I got 7 in? Oh, that's important. Yeah, okay. Is it? I don't think it's true, so I don't trust it at all. Why have I got 7 pencil marked there? Why have I done that? I've got 7 here. I don't believe that. Because I think what I've done is I've said this can't be 7. So I've looked at this, or I've thought, or maybe I haven't seen this pencil mark or something, but I don't see why they have to have 7 into one of those squares. I mean, it might turn out to be true, but I don't think it's necessarily true. Why couldn't that be 1, 4, 7? And then this would be a black digit, and that would be a 7. And these would both be black. I don't think there's anything wrong with that. I'm disputing that corner pencil mark there. I wish I didn't have to. Oh, these two squares can't be 4, though. Oh, that's nearly interesting. That is nearly interesting. Whether this is 1 or 7, it's interesting. 1, 2, 3 would be how it would have to go. Is there a reason that doesn't work? It might be. I don't know what it is, unfortunately. This is one of each down here. 1 orange, 1 black, 1 yellow. And 4 in this column. Could it be here, or does it have to be? If it had to be in the 17, that would be interesting, wouldn't it? Oh, it's nearly true that 1 has to be in this 17. Because the only way it isn't is if 1 is here. So if this was 179, this would be 1 or 9. I don't know. Sorry, I'm getting bogged down, aren't I? Oh, wait a sec. Well, okay, we've had all these 2 digits are yellow and black in the column. Yeah, so 2, 3 works nicely. If this was 7, these would have to not in. That would be a 3. This digit would be 7, 6 or 8. Yeah, that might be possible. I don't know. Oh, hang on. Is that a 1-7 pair I see before me? Because that means that square is not 1 or 7. Which means this square is either black or yellow. Both of these are black or yellow, in fact. So this must be orange, I think. It sees where it's just a case of where orange goes. So this is a 1-7 pair in box number thingy. This digit is yellow or black again. So these are opposites in order for row 2 to work, which means one of them is yellow. And that means that this can't also be yellow, otherwise there's too many yellows in box 2. So that is black. So it is 2 or 5 only. Oh, come on. Come on now. How do we finish this off? I'm not even sure we're at anything like the stage where we're finishing this off. But let's keep going. Now these are yellow and orange. And they are different. And oh, but hang on, I know there's a yellow down there, so that's not yellow, that's definitely orange, which means it's definitely 4, which means this is definitely, you've guessed it, yellow. So that's 3, 6 or 9. In this column now, these two, oh, this is useful. Yeah, these are black and yellow, which means these are black and yellow, I think, by counting round. If that's yellow, that's yellow. If that's black, yeah, so these are yellow and black. And we know that we've got difference. Yeah, I thought about whether these could all be the same, and I concluded they couldn't be. So this is orange. It's orange. And now, well, I don't know what it means, but it's exciting. This is not 1. This is not. That could be anything. Ah! Okay. No. No! You've got to be kidding me. Oh, hang on. Now, I have got a black digit in here along. So this has to preserve the modularity. That's got to be yellow, doesn't it? This cell? Because overall 17 has a 2 remainder, and we're on a 2 remainder with a black and a yellow. So that's got to preserve modularity. That is yellow, which is the last yellow look in this column. So this digit, well, it's orange or black. I don't know if I know which. Okay. Well, does that help me though? These 2 digits are. Could they both be black? I mean, these are different. I know that. These are different. Those are different, and those are different. Now, does that help me? Oh, there's no 7 and no 8 in my 17 cage anymore, because that digit's got to be a 3, 6, 9, and I've got 7, 8 in the column. So maybe this is limited. It must have to have 9 in it. 6, 5, 4 isn't enough to get to 17. So there's a 9 in here, definitely. One of those 3 is a 9. and then 2 digits that add up to 8, which are not 1 7. In fact, they've got to involve a 2 remainder digits, so it's either 2 6 or 3 5. Oh, 3 5 could work, even with a 3 here. If that's 3, and this was 9 5, would that not work for some reason? I don't know. Let's try the other way round with 2 6 and 9. I don't know. I'm not sure. 4 is definitely in one of those squares. Oh no. So okay, sorry. I can't be far away, can I? Famous last words. These are... Okay, I know what... Right. Yes, I know this one, I think. The way I'm seeing that is I know this is... One of these is a black digit. I know one of these is a black digit. So that's all my black digits. This sees 3 yellow digits. So that's got to be an orange digit. And that is therefore a 7 because it sees a 1-4 pair. That's good. That gets me a bit more thingies. Technical term. This is a set. Oh, that's 7 on a dot now. That's a 1 by Sudoku. 7 on the dot can't link to a 3 within 2 consecutive goes. So the 3 has got to be here now. That might do something. Oh no, please. Please think about doing so. Oh, hang on. Look now. I've got lots of things. Those are both black, which means, and we know these are different. We can count along here, can't we? 1, that's black. This is beautiful now. So black is not 7, is it? So this has got to be, and that's got to be orange. This is therefore 7. So this is, oh, well, is that true? Is that definitely an orange digit? Yeah, that is orange by dint of the trapezium. So it is a 4. And this can't be orange because it sees too many orange digits. That's got to be 2, 5, 8. And now that's a 4 by dint of Sudoku. So there is, yes, there is a 4, look, in that 17 cage. So there's no 1 in the 17 cage. Because the 70, if it had 1 in it, it would be 1, 7, 9. So the 1, 4 go in like this. 4 goes in the corner. 4 is an orange digit. 1 is an orange digit. 7 might go in there. 11, we need a 6 here. Could that be a 6? Yes. I mean, those 2 digits add up to 13, don't they? So they're either 7, 6. They can't be 4, 9 without repeating the 4, or they're 5, 8. But we know so little about 5. 5 and 8 would make... Oh, this is right. Right. What we do now is we look at these white dots. This digit is 6 or 8 by dint of white dottage. So this is odd because across a consecutive pair you must have an odd digit and an even digit. Now, if this is 6, 7, that would be 8, 9, and that would be okay. But when I thought about this before, I thought 5, 8 was giving me a problem. Maybe I'm wrong. I am wrong. No, I'm not wrong. I'm not wrong. This digit can't be 7. It's got to be from the right set. Yeah, if this is 5, 8, that's a 6. And what's this? It can't be 5 if this is 5, 8. It can't be 7. There's already a 7 in the column. So this is 7, 6. That's 8. That's therefore 9. Now we're going to have to colour all these in a moment, but let's keep... Oh, that's not 9, but I still don't know where the 9 goes. That's not 6 by Sudoku. So that's the same digit as this. This is a 6. This is a 9. This is a 6. This is a 6 now. 3, 9. That's not 6. I really want to colour these in. 2, 5, 8 are black digits, aren't they? 9s and 6s are definitely yellow digits. 7 is definitely an orange digit. So these are both black digits. They're a 2, 5 pair, in fact. So that's an 8. That's an 8 by Sudoku. This is an 8 by Sudoku. That's an 8 by Sudoku. What a puzzle this is. I don't think this is very easy at all. Where is 3 in this column? And that seems to be the only place it can go. So that's yellow. Therefore, this is black. It's 2 or 5. This is where all the comments will go, no, this was very straightforward. You could have just done this, this, and this. And I will feel like a prize Charlie. But I don't know. I'm not sure that's true on this one. This felt complicated to me in sort of the best way. Gosh, I'm an hour and 20. Where does the time go? Where does the time go? Good grief. Right, I've got 3 oranges and 3 blacks here. So that's yellow, which is the final yellow of that column. So that's 9. That's 6. I've just had an interesting thought, actually. No jokes, please. There's definitely there's 3 in there. So this is a black digit. I'll tell you my interesting thought. And that's the 3 plus 4 is 7. So the 12 cage needs a 5 in it. So that's 2. That's 5. That's 2. That's an 8 now. That's a 2 by Sudoku. So that's an 8. That's a 2. That's a 2. That's a 5. Oh, please, please don't. Oh no, it is still going. We are still in the game. 6, 9. Yeah, we're still in the game. 6, 9. 9 here, because I'm saying there's a 3 down here somewhere, apparently, for reasons I'm not sure now I can recollect, but it does seem to be true. That's 5, that's 5, that's 2. 2 goes here, that's a black digit. There's a black digit here. There's got to be a 7 over here, so that's going to have to be there. This is therefore definitely yellow, and definitely 3 or 6. And I'm just going to have to work out what this is. We could use the secret. It's something I'd share with only my very favourite people. It feels the right way to do it. If you're watching this video, definitely one of my favourite people. Thank you so much for staying with me. But look, we've got 70. The secret, by the way, is that this box adds up to 45 because it will contain all the digits 1 to 9 once each. So what have we got here? We've got 22 there, 39. So this has got to be a 6 to make us up to 45. So 6, 9, 9, 3. 9 is therefore exactly there, which makes this a 3. So we're on 12. We must need a 5. That's a 3 and that's a 5. And all that remains for us to do is to black those 2 and yellow those. And I might have messed up somewhere with my colouring, but I do think that was logically solved. It was really... Oh, bobbins. Not even a 3 in the corner. Oh, no, there wasn't. But you may still sing if you like. It's my party and I'll sing if I want to. Hardly anyone solved this, but it was fabulous. Dying Flutchman, what a puzzle. What a puzzle that was. I think the thing I've struggled with, and this might be where people can really get a march on me, I couldn't do the colouring. I knew what I wanted to do, but I couldn't see how to relate the colouring across the grid in any useful way. I struggled big time with where you should start the colouring. And then I had sort of 2 colour schemes going on and these red lines going on. And then maybe there was a point at which I could have done the colouring in a more sort of structured way, or a more uniform way, and you will let me know in the comments what I missed. I've no doubt. I enjoy the comments, especially when they're kind. And Dying Flutchman, take a bow, and we'll be back later with another edition of Cracking the Cryptic.